Welcome. I want to talk first of all about this class and what we're doing. This class is ITSC 2359. It covers advanced computer programming. So we're going to do a little refresher on what C++ is and then jump into more advanced concepts really quickly. The class will move fairly fast. We want to address some review of stuff you've probably learned before. And to do that, I'm going to jump into code spaces. And to do that, we're going to make a quick repository. So I'm going to go to github.com. And if you're not familiar with github.com, please get with me so that we can make sure that it makes sense. To create a repository in github.com, and if you haven't created a username yet or profile, go ahead and log into github.com. And let me just log out and show you kind of what that looks like. It's going to sign out. You would hit sign up and you would fill out the sign up process and create an account. I already have an account. I'm going to use that account to log in. And when you've logged in, you can create a new repository. And here's a repository, and I'm going to name this repository for the purpose of this class, ITSC 2359. We're going to say, what should we say here? ITSC 2359. We'll just say test for right now. And we're going to make this repository public, and that way everybody can see it. And I'm going to add a README file. It's very important you check add a README file in order to make a code space off of this program. And I'm going to go ahead and create that repository now. Repository is now created. It has a README file, so it's not empty. I'm going to go to code spaces, and I'm going to hit new code space. And I'm going to select the repository I just created. And to look that up, I'm going to say ITSE. And of course, this is the 2359 test. And I'm going to create that code space. All right. And what will happen now is code spaces will load, and it will load with a folder that says ITSC 2359, and it will load with the terminal working, and it will load with the coding window. Okay, so in this first lesson, we're just starting with the basics. What is a computer? At its core, a computer is an electronic machine that can perform arithmetic and logic operations, but it's the software that gives it purpose. Without software, your laptop or computer is just an expensive paperweight. So we're going to look at a short C++ program that reflects this basic idea. To do that, there's really two ways of opening a C++ program. One is using touch, and I'm going to show that now. I'm going to just say touch, and we'll just call this one main.cpp for now. And when I type in touch, it doesn't open the file, but it saves it. I'm going to go ahead and open this up. I'm going to say for every program that I will code in this class, because we're working from the console, we're going to include IOStream. And we are going to use namespace std, that stands for standard. We're going to create a main file with an int return, so we're going to always just return 0 or 1, it doesn't really matter what you return there. And I'm going to output to the console a couple of things about a computer. And I will output this. This is the definition of a computer. A computer is an electronic device that performs arithmetic and logical operations. I'm going to end that line. And then I'm going to come down, I'm going to type in another line using that same concept. So I'm going to go and end line here. And close those parentheses there. Everything looks pretty normal with the colors, so we know it's good. And I'm going to go ahead and say that software provides instructions to the hardware to make it useful. So these are good definitions to have. To kind of run this program through, we'll spend more time talking about this in subsequent videos, but just so you're aware, and I went in and clicked the install to install the C++ extension pack. While that's installing, this is the main program. It has an int return. So on line 8, we had it return 0. This COUT stands for console out, and we're sending these literal strings out to the console when we run this program. Control S saves it, right? Please, understand this definition, because that's important for us as we move into the world of computers. All right, the next thing I want to talk about is what hardware and software do. Hardware includes physical components, a CPU, RAM, disk drive, and monitor. So I'm going to go ahead and do something real quick. All right, and I'm going to copy this line here a couple of times. This just creates basically line feeds. But what I want to put in is a definition. So hardware includes physical components like CPU, RAM, disk drives, and monitor. Software includes programs that tell the hardware what to do. All right, so those are the two basic parts of a computer, the hardware and the software. The CPU is the brain of the computer. It does all the calculations and makes decisions. Memory, or RAM, holds data temporarily while the computer is on. Here's a short simulation that shows what a simple calculation does when it's happening in memory. And I'm going to go ahead and just copy that program over, right? So I'm going to say memory simulation. And now, of course, it's going to give me an error message almost immediately. It's going to say that this identifier is undefined. So on the top, I'm just going to say this. I'm going to say void memory simulation. Now it's defined, and that should go away if I spelled it correctly. Simulation, I did not spell it correctly. Memory simulation, so that error now goes away. So this is going to call that, and what I want to do is just basically run a quick program where we have this simulation happening, right? And that program looks like this. I'm using namespace std, so I don't need these std calls. But when I built this program earlier, I did call std. So there we go. All right. Let's go ahead and run this program and we'll see what's happening with, that should be a comma, not a semicolon. All right, that fixes that error. We're going to run this program now, and we'll see exactly what happens. So I'm just going to go ahead and compile this, and I'll compile that doing G++. And what that does is it does compile the program, and it compiles it to a.out. I'm going to /a.out, and we can see what happens. It tells us the computer is an electronic device that performs the arithmetic and logical operations. Software provides the instructions. Hardware includes the physical components. Software includes programs and operating systems that tell hardware what to do. CPU adds 5 plus 7 equals 12. This data was stored in memory or RAM during execution, right? That kind of brings us to secondary storage, While RAM is temporary, the primary storage but temporary, secondary storage devices keep your data even when the power is off. Now, part of the function of this course will be learning about input and output and maintenance of the data even when the program is off. That talks about file integrity. But let's just address what secondary storage devices are. And to do that, I'm going to create another method that just says secondary storage, right? And that function, I should call it a function in C++. We're going to say void secondary storage. And what kind of secondary storage are we talking about? Well, secondary storage examples would include the hard drive, an SSD, USB flash drive, CD-ROM, for example, or a DVD-ROM, whatever you think secondary storage might look like. All right. So, of course, we are discussing the developer side. So, how do we develop software where users can interact with the program? Well, in C++, we can use things like keyboard or really anything, but we need to script that out, right? And so to kind of look at that, let's see how we would develop a quick program that shows user interaction. So I'm just going to create a program real quick that does some user interaction, and it's going to be fairly straightforward as well, right? Nothing earth-shattering this time. The way we do shows user interaction is simply declaring a variable and using console out, as you've already seen, and console in to work with that variable. Right? And I will write this program here. So now we have a variable declared. We've sent to the console this message, enter your name. We allow the user console in to type in their name. Then it says hello. This demonstrates input output in C++. And let's go ahead and again compile and run that program. We can see how that works. Right? Enter your name. I'm going to just say Chad for me. Hello, Chad. This demonstrates input and output. Next question might be exactly which programming languages are running, right? Well, computers speak binary, but programmers run higher level languages, right? And just to kind of, without going into a lot of depth, you will get depth later on in your life as a developer. We're just going to jump in and talk about some simple things, and that is that machine language is binary. Assembly language is very specific directions to the computer, and a high-level language looks more like, what you write here in the window is a high-level language. And so we are going to create a program called, or a method called language examples. And here, we're just going to do this. That's not right. That's the same old function, so we're going to delete that. And I'll put in some examples of what that looks like. And of course, the textbook goes in more detail here, so if you want to read through chapter 1, you can. But these are machine languages, assembly languages, and high-level languages. This kind of makes more sense as you go down to the high-level language. All right. Now, if we look at the basic structure of a C++ program, I just want to address that here in our, and by the way, I need to type in that language examples here. All right. You can see that the main function is where program execution starts. But if we call a function within our main method that has not been declared above the main program, it doesn't know what's going on, right? We use IOStream for input and output, and we use namespace standard to allow us not to have to type an std everywhere, right? All right, so we're coding here like we would code in Python, where our functions are defined above the main function. We can also use this as header space. So we can just say, you know, there is a function that's memory simulation, and that's the header. So that still works. And we can build it at the bottom. So we can code this way too, right? If you wanted to, if you really like, and a lot of developers do this. So just letting you know, this is also functional, right? So now it's declared up top as a header, and this is the implementation of that function that's called. So when it calls memory simulation, it looks for the space declared in memory, and now we have this reference here where that memory simulation is particularly embedded. So we can go ahead and run that, and you can see it still runs the same way, even with that structure. There's the memory simulation that still works. Okay. Now, programming is about solving problems. So we develop programs in order to solve problems, and we don't know what those problems are going to be, right? But we know there's some steps that we basically use every time we solve problems. So let's talk about problem-solving steps. Again, you can see there's the error we get when we don't have things defined, right? So up here, I'm going to just type in void problem-solving steps. And we have like 4 steps in solving a problem. And those steps are as follows. We analyze the problem. We design an algorithmic solution. We implement the algorithm in code, and then we test and maintain the program. So let's apply this. What if somebody was going to ask us the perimeter and area of a rectangle? Well, we might know, so let's kind of talk about perimeter of a rectangle. So we will just go ahead and say void say rect perimeter. What sort of parameters does a rectangle need to find the perimeter? Well, a rectangle needs length, so we'll say let's do a float for the purpose of this. Float length. And float width. We're actually going to say double length and double width, just because. All right, double width, double length, and double width. Okay, those are the parameters. And to find the rectangle area, we're also going to need length and width. So those are the parameters we need to do this. And what's the algorithm to solve it? Well, to find rectangle perimeter, we need to do 2 times L times W. 2 times length times width. All right, so we're going to go ahead and create this rect perimeter method. We're going to build it here, rect perimeter. All right. All right, and then we're going going to return, we're going to return 2 times length times width. All right, so there's rectangle perimeter. And then we're going to go ahead and do rectangle area. Of course, we're going to make this a double method. And up top, we're going to make this double as well. Because now I have a return value, so we need to change that from void to double for both of these. All right, so here's double rect area. How do we find the area of a rectangle? Well, to find the area of a rectangle, we just multiply length times width. This is actually not the right. This is not how to find the perimeter. I apologize. It's 2 times length plus width. So we are going to do that here. 2 times length plus width. All right. And that solves the perimeter problem. And the area is, we'll go and comment this here. Rectangle area is 2 is length times width. Okay, so I'm going to go ahead and output this using a method. So I'm going to say, we'll do it down here. Actually, for the purpose of demonstrating this, I'm going to go ahead and block comment out everything below this line using /* and */*. And then I'm going to demonstrate now the rectangle area. And we'll do the same thing with rectangle area, just calling area as well. Okay, so once we do that, it will call the perimeter method. It's defined up here, implemented down here, and it will call the area method, or function I should say, which is defined up here and implemented down here. So let's go ahead and run that program now, and you will see it work. Rectangle perimeter is 16 and the area is 15. Obviously, we had a couple of problems, and that is that when we output this, we probably want to have that inline function. So let's go ahead and do that. And same thing for the next thing. All right. So now, there we go. Rectangle perimeter 16, rectangle area 15. So the question is that correct? Well, if we have a length of 5 and a width of 3, then the perimeter is 18 and the area is 15. So we can see this implementation worked successfully. And finally, let's build a more practical example. This program is going to calculate the average of 5 test scores. And how do we do that? Well, and a lot of these concepts that I'm addressing, we're going to address in more detail later on. But I'm going to show off what an array looks like, and then we're going to go from there. So I'm going to say student grades. So let's implement a student grades average program, right? And I guess we will make this a double because we're doing and we're just going to run this with no method calls here, right? So I'm going to go ahead and say and by the way, just a side note, if you're debugging software, it's awesome to use this block comments, right? So we're going to go ahead and say student grades average, all right? And the student grades average, we're going to implement that using a full array, right? And that's going to be, in fact, I'm just going to show this function over here without a double. Let's just make this void. I think that's how I originally had it set up. So we're going to make this void. We're going to make this void as well. All right. Okay. That fixes that problem. And this is going to show if there's an average grade, what's it look like? So let's go ahead and run it, and you'll see what I'm talking about. Average 86.8, grade is B, right? So what's the purpose of this program? This program calculates an average of 5 test grades. It assigns a letter grade using conditional logic. So in this program, we have an array declaration, which is kind of cool. We'll learn about this next week, or in the next few lessons, I should say. And we also have an iteration here. And we have a selection here that calls through the grade average to see what the actual average is going to be. Okay, so really that's all I want you to look at for chapter 1. Please read the chapter, but this is kind of a rundown of everything covered in chapter 1 without digging into the weeds. But please read the chapter and know more about what's happening in chapter 1. Thank you.